Okay, so good morning, everybody. My name is Jamie Littlefield. I'm a PhD student from Texas Tech University, and I'm excited and a little bit intimidated to talk to you this morning about an emerging career path that I think holds a lot of potential for tech comm graduates, and that's AI fine tuning. It's not widely discussed right now, but there's an entire ghost work economy where thousands of technical communicators are already engaged in shaping the values, the output, and behaviors of AI systems. This work often happens behind the scenes, but it's absolutely critical to how these systems develop and function. So, this is me, sort of. I asked Rock to make me into any kind of meme, and this is what it came up with. My experience with fine tuning began last summer while I was panicking about the field of tech comm at a graduate student event, actually in Dr. Sauer's backyard. I started to realize that AI might change everything about what I love to do, and I was very worried. If Gen AI is a machine of loving grace, um, we don't need to look into that black box. And if generative AI is an unredeemable weapon of math destruction, then maybe it does make sense to stay away from it completely. And I do understand that perspective. But I think it's some kind of a third thing and something that we need to try to find some ways to take some kind of responsibility for. So this led me to take on a 6-month full-time contract fine tuning an AI model, like a large language model, at an AI company. And while I can't discuss the specifics due to confidentiality agreements, I feel like I must have been asked to sign more disclosures than James Bond. I can speak about the industry more generally and also my experience within it. What's particularly notable is that technical communicators are already engaged in fine tuning work. The job listing that I responded to specifically asked for tech comm skills. Many of my colleagues came from technical communication backgrounds, and the work that I was doing was, at its core, technical communication work. And as we're all aware by now, AI is changing our field. And rather than seeing it as a threat to technical communication careers, I want to explore how technical communicators are uniquely positioned to shape AI development. And so today I'm going to talk about what fine tuning is, why it matters for technical communicators, and how we as educators can prepare our students for these new opportunities based both on industry trends and also some of my own experience. So let's start by understanding what AI fine tuning actually is and why it presents such an exciting opportunity. Fine tuning is a process of adapting an AI model to perform specific tasks or to better align with human expectations or preferences. It's essentially a way of refining a model's outputs and behaviors after its initial development. And this work is particularly important for large language models like those powering ChatGPT, Claude, Grok. While these systems have impressive capabilities out of the box, they require careful fine tuning by humans to make them truly useful, accurate, and safe, and also relevant for specific contexts. What makes this field promising for technical communicators is that so much of the fine tuning process doesn't require deep machine learning expertise. Instead, it draws on the skills that are central to our discipline, like clear writing, audience analysis, ethical reasoning, and the ability to evaluate communication effectiveness. So basically, fine tuning is where the human touch enters AI development, where we shape these systems to communicate in ways that are helpful, clear, accurate, and hopefully aligned with human values. And that's exactly the domain where technical communicators can excel. So, to better understand why we're suited for this kind of work, let's look more closely at how large language models learn. And of course, all of this is going to be a simplification because, as we all know, this is complex algorithmic work that has a lot of moving components and is different between different AI companies and different models. But basically, the learning process typically occurs in two main phases. First is the pre-training, which is the initial phase where the models develop general language capabilities from massive data sets of text. This is often scraped from the web where the copyright concerns come in. Pre-trained models have broad knowledge across domains, strong language understanding, and basic reasoning abilities. However, they also have limited control over their outputs and their behaviors. So the second phase, and this is what I'm talking about here, is fine tuning, where models are further trained on carefully curated data sets to shape their behavior in specific ways. So this transforms the general purpose model into one that ideally more fully aligns with human values and ethical principles, follows instructions, resists making harmful content, etc. It's important to highlight that right now, our technical communication scholarship often discusses biases as emerging from the pre-training data. And while this is certainly true, fine tuning is also a critical site where human preference enters the picture and annotators introduce their own ideas, ideologies, values, and biases. This isn't necessarily negative. In fact, fine tuning is where we are deliberately trying to shape AI to align with human values. But this process requires careful consideration and ethical awareness. And this is why technical communicators have such important work to do in this space. Our training in ethical communication positions us to make thoughtful contributions about how these systems are fine tuned to communicate with humans. Here's just a quick and silly example of fine tuning. About a year ago, developers wanted to make large language models seem more human and personable. And so many AI companies had their annotators favor responses that were particularly friendly. And so you might remember large language models that started every single response off with something like, certainly, or of course. The models were fine tuned to do that. But then over time, it went too far in the other direction. And some large language models started to feel almost servile and inauthentic. So again, human annotators intervene in the fine-tuning process to balance things out. These behaviors from the large language models didn't just come from scraping Reddit. They came from humans working to fine-tune these systems. Humans behind the scenes were influencing the machine behaviors, values, and ways of thinking. And then that human judgment was then translated into model weights, like the temperature settings that we saw in Dr. Sauer's presentation that changed the model output. So a key technique used in fine tuning is called reinforcement learning from human feedback, or RLHF. And I think someone might have a microphone on. So if your microphone's on, you might want to turn it off because it's a little bit squeaky. So RLHF, this diagram shows.
Sorry, you just got muted there for a second. Can you hold on? Yeah, the whole room got muted. Hold on a second. I'm trying to fix that for you. Um, there you go. You're good.
Good. Awesome. Thank you. So I'm not quite sure where I cut off there. So I'll start about um, just talking about the pre-trained model, which we discussed a couple minutes ago, has already been trained on a large corpus of text from diverse sources. So then we move to the dataset stage. And this is where carefully curated model inputs and outputs from the pre-trained model are collected to serve specific purposes. And some of these data sets might focus on factual knowledge, others on creative writing, and still others on handling sensitive topics appropriately. The quality and diversity of these data sets are crucial for effective fine tuning. Next, we have the data sets moving to being evaluated by human annotators. And this is where technical communicators often play a vital role. These annotators judge and rank model responses based on various criteria: accuracy, helpfulness, harmlessness, personality, clarity, tone, and more. So they're not just saying, well, this is good or this is bad, but articulating why certain responses are preferred over others so they can come to an alignment. These human judgments are then fed into the reward model, which learns to predict human preferences. The reward model essentially tries to answer the question, how would a human rate this response? This model becomes the mechanism through which human values and preferences are operationalized into the system. And then finally, the feedback loop takes all of this information back to a version of the pre-trained model, using the reward model's predictions to guide the model towards generating better responses. So this iterative process progressively improves the model's performance according to human values and preferences expressed through the annotation process. And the critical component in this entire system, at least in my view, is the human annotators, the people who provide judgments about which outputs are better and why. This human in the loop approach requires people to understand communication principles and articulate why certain outputs are more effective, accurate, and appropriate. It's not just about having opinions, it's about having informed, consistent, and well articulated judgments about communication quality. So let's look a little bit more closely at the actual work involved in fine tuning. This goes under different names for different AI companies. There's not like a consensus on names. So you might see people just being called annotators, but then their work goes into different directions. Um, there are people who are called AI trainers, AI tutors. There's not like there's not consistency across the companies quite yet. But while there's technically well, there's certainly a technical side involved in learning this. A significant portion of the work does not require advanced machine learning expertise. Instead, it involves writing ideal model responses that serve examples from the model to learn from, evaluating conversations between users and models, annotating outputs with labels to categorize different kinds of responses, rating and ranking model outputs based on quality criteria, working with multimedia images, um, text, videos, voice, and there's a lot of fun work being done right now with all kinds of people, like comedians, artists, voice actors, producers, and they have technical communicators working with these people to create the kind of content that users are looking for. Developing evaluation frameworks to systematically assess model performance and weakness, and documenting decisions to ensure consistency and provide rationale for the choices that have been made. So now I want to show you pretty quickly what this work might actually look like in practice. So this is a screenshot from Labelbox. It's a popular annotation interface that's often used during the fine-tuning process. And what you're seeing here is a comparison of two possible responses about a platypus. And the left might be technically accurate, but is extremely dense, filled with scientific terminology, and maybe overwhelming for most users. And the right is a bit more concise and accessible, while still having some accuracy. So when an annotator, and this is a simplified example, obviously, but when an annotator evaluates these responses, they aren't making just a simple preference judgment. They're engaging in sophisticated rhetorical analysis. So who's the presumed audience? What level of detail is appropriate? How specialized should the terminology be presented? Is the tone appropriate for the context? In my experience annotating some similar outputs, we were constantly making these kinds of rhetorical judgments, drawing on principles that be familiar to any tech com professional. We had to balance accuracy with accessibility, comprehensiveness with concision, and formality with engagement. Here's another example of annotation work, this time evaluating the RAG search results that a large language model might incorporate into its responses. So in this interface, the annotator is evaluating different potential sources about the impact of AI on jobs. And the annotator's job here isn't simply to pick the correct source, it's to assess which search results the LLM should incorporate into the answer by considering two factors. First, they have to evaluate the bias within each result. Is it presenting a balanced view or is it leaning heavily towards one perspective? And then second, at the bottom of the interface, they have to determine the relevance of the results to the answer that the large language model is constructing. So these evaluations end up directly shaping how the AI model will select and incorporate information sources in the future. By providing this kind of feedback, annotators are essentially teaching the model which information sources to trust, how to synthesize information from multiple perspectives. And again, this is drawing on that same TechCom skills that are central to our courses, determining source credibility, recognizing bias, synthesizing information for specific audiences and specific purposes. Okay, this final screenshot shows an evaluation framework that's being applied to an AI response. And the query at the top asks about system requirements for running Label Studio. And below that, we see the annotator has provided specific instructions to the model and is now evaluating how well the model has followed those instructions. The response has been evaluated across multiple dimensions. There's a quantitative scoring system for faithfulness and answer relevancy. And below that, there's a text box for documenting the annotator's reasoning. This type of systemic evaluation requires a sort of metacognitive awareness about communication. So the ability to analyze not just what is being communicated, but how it's being communicated and why certain approaches are more effective than others. Okay, so why does this matter? For technical communication students, understanding fine tuning, I think, offers several benefits. It helps them develop and apply their existing skills in new contexts, and it opens up potential career paths in a growing field. We don't know what the future holds and whether this might be done synthetically in the future, but for now, it seems to be holding that we need humans in this loop. It provides a deeper understanding of how large language models function, which I think is increasingly important in any professional setting. And then for the field of technical communication, engaging with AI fine tuning is significant because technical communicators are already doing this work, often without formal recognition from the field. It provides an opportunity not only to critique AI with our skills, but to help develop AI with our skills, even though we may not all have machine learning expertise. And I think this last point is particularly important. Rather than just responding to AI after the fact, technical communicators can shape how these systems communicate from the ground up, bringing our expertise to the development process. Every judgment made by a human annotator potentially influences thousands of outputs by a large language model, so it has this cascading effect. Okay, so let's talk about why technical communications are so well positioned for this field. Um, we, I think our students are already developing many of the skills that they're going to need to succeed here. And as we've discussed, they don't need to become machine learning experts or data scientists. Let's think about some of the core competencies we already teach in our programs. We already help students develop a deep understanding of audience needs, which is essential when evaluating whether an AI responds and actually addresses a user's question effectively. We teach them to write clearly and concisely, which are skills that are directly applicable when crafting ideal model responses or explaining why a particular output falls short. In my work with an AI company, I found myself constantly drawing on the skills that would be familiar to anybody who's taken a tech comm course. For example, organize information, maintaining consistent style across materials, or documenting processes for others to follow. All of these tech comm fundamentals directly translate into fine tuning work. I think that the greatest asset our students bring to this field isn't technical knowledge about machine learning, but rather their ability to assess communication effectiveness and articulate why certain approaches work better than others. This critical eye for effective communication is exactly what's needed in this space. So while our students already have a strong foundation, there's a few skills they'll need to develop to be prepared for this field. Um, And I want to emphasize we shouldn't feel intimidated by this list. Many of these skills are natural extensions of what we're already doing, but prompt engineering is one of them, especially adversarial prompt engineering, trying to get systems to jailbreak to see what can go wrong. We're talking about um, figuring out the presence of bias, using our ethical judgment to determine when there's even subtle bias. And LLM companies are increasingly focusing on the need to be able to find this kind of content. Um, Trying to hurry up for time a little bit, but I have found that domain experience is becoming really important as well. Companies are looking for people who understand AI and then also specific industries. So healthcare, finance, or other specialized fields. So it's, pardon me. Perhaps most importantly, students need to develop the ability to clearly explain their rationale. So it's not enough to say this is better. They need to articulate why using consistent evaluation frameworks and clear documentation. So here are a few curricular recommendations. Um, I would suggest that we probably start just by putting in AI evaluation assessment assignments into our existing courses. So let's have students start looking at AI inputs, AI outputs, and evaluating them and comparing them to different models and against each other. I think that this kind of work helps And I know we talked about critical being a problematic term, but it helps students develop kind of a critical awareness for AI in general. Pardon me. So to summarize, fine-tuning roles represent significant career opportunities. And I believe that our programs are uniquely positioned to prepare students for this work. And by focusing on both the technical and ethical dimensions, we can help shape the future of AI development. Apologies for the the coughing at the end there, but thank you so much for listening to my presentation, and I'd be happy to take any questions.